Hello, let's continue our Sudoku adventure with 4 Ridiculous Facts About Chaos by GDC. So, this continues our Chaos Construction Theme Week. This is 2 out of 3 puzzles by GDC for this week. Beginning of the week, I said there were 2 puzzles. There's actually 3 by GDC. So, GDC is the Chaos Construction Master. So, let's go over the rules to this one. So, we do have standard 6x6 Chaos Construction rules. So, in every row and every column, we are placing the digits 1 to 6 exactly once each, but there's also regions hidden in the grid, such as this one. This may not be one, right? But this would be a valid region. There are 6 regions of size 6, and so every cell is part of a region. Regions have to be fully connected by borders. So this would be a valid region. This would not be, because they're only connected by a diagonal, not by a border. And this definitely wouldn't work. This definitely wouldn't work, because the region has to be connected. The entire region has to be fully connected. All right, now what are we doing with these regions? Well, they also contain the digits 1 to 6 exactly once each. And so they're kind of like the Sudoku box, right? But they could be any shape as long as they're fully connected. And yeah, so we need to use the other rules in order to find where these regions are, because they are not given. All right, we also have these internal X sums. So a digit X in a circle counts how many cells of its region it sees in the row and column combined, including itself. So whatever digit we fill in here is how many digits it sees in its row and in its column, including itself, before it's obstructed by a border. So let's say we had a region of this shape here. Well, what digit would we put here? Well, these are the borders. This would have a border all around it. And so in its column, it actually sees itself only. Because it immediately hits a cell border here and a region border here. So it does not count this one because there's a border in between. And then in its row, it sees 1 cell. So that's 2 in total. You don't double count itself. And so we put a 2 there. And now how is that 2 used? In addition to it just being a 2, the number in the square, this 8, is the sum of the cells that it saw in order to count to 2. And so then we would put a 6 here, and that would sum to 8. So that would be one way that this region would work. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Now, we weren't told that the circles are all in different regions, so these could be the same region as each other. So how do we want to get started here? Okay, so maybe we think about, first of all, what digits could go in each of these circles. So a sum of 7. This certainly can't be a 1, because then it would only count 1 cell. I don't think we can ever put a 1. We wouldn't be region-wise, we wouldn't be able to put 1 either, because then it would have to be surrounded by borders immediately. So yeah, 1 is definitely out. 2 would work. We could do 2 plus 5. 3 does not work, because the only way to get to 7 and 3 is 1, 2, 4, and that excludes the 3. Right? If you try to use the 3, you need 4 more, and the only way to get 4 and 2 more cells is 1 plus 3, so we'd repeat the 3. So this actually has to be a 2. 4 is too big. 4 sums to 10 minimum. 1, 2, 3, 4 is 10. So this is a 2, so there is going to be a 5 in one of these 2. Now, the 5 can't be here in this circle, because 5 cells sum to 15 minimum, and that's a 9. So this is a 5. And these are part of the same region, because they have to be, according to the rules of the circle. It only counts cells in the same region. Okay, I am going to just immediately draw a border around the entire grid. All right. So now 9, this can't be a 2. It's not 1, it's not 2. So it has to be 3, because 4 is too big. 4 sums to 10. So this is a 3. So it's going to see 3 cells in its row and column. And they're going to add to 9. So the remaining 2 cells are going to add to 6, which is going to be 1, 5, or 2, 4. Because 2 and 5 seem to affect that in some way. So 3 includes itself. So it's going to be hard for this to... how does this work? So let's think about whether this could be green. If this was green, we see the 3 and the 2. We get to see 1 more cell, and that's it. So we could put along with this 2, we need a 4. We could have put a 4 in one of these 2 cells, and then the region could then grow down to here. So we could do a region just like this, with a 4 somewhere, and then this would be 1, 6, And I think that, oh no, we couldn't do this. Sorry, what did I, we would continue growing down like this. Oh no, but the two, hold on. I can draw some region borders here, because 2, oh yeah, sorry, this is obvious. This is obvious. I cannot include this because, sorry, I'm still understanding the rules here. If this was green, the 2 would see 3 cells, right? So it's definitely not green. It is definitely purple. There's a border here. And then there also has to be a border here because the 2 can only see 2 cells. We need to immediately hit a border after seeing this 5. So now green has only one way to grow because it can't grow this way or this way, and it needs to grow because it needs 6 cells. So it grows here. There's a border here. And so now this 9, it needs to see 3 cells in its row column. It only sees the 1. It sees itself, but it doesn't see anything else in its column. So it's got to get those 2 from the row, and then it has to stop. And then these, we can't use the 2, so these are 1, 5. I don't think green can take the 10. Can it? Oh, I think it could. No, yeah, I don't think is that a problem? So 10 is interesting. So let's think about what digit could go in it. Definitely not 1. 2 would require it to add with 8. That doesn't work. 3 would require it to add with 7. So 3 could be with 1, 6, or 2. So 3, but it sees a 3. So this has to be a 4, and it has to be 1, 2, 3, 4 that it sees. So it can't be green because it doesn't see the green 2. So, and it's not purple because purple it wouldn't see the purple 3. So this is a new region. This is the orange region. We can draw this border here. So it's got to see 4 cells, and it's got to exactly see the 1, 2, 3. Green has to continue here, so we get this border. So this isn't 2, 5, 3, 4, this cell. So this is 1, 6 only. How about 8? So we can't do the 1. We could do 2 plus 6. We could do 3, 1, 4, and that's it. So this is 2 or 3. Okay, wow. The fact that this is all we need is actually a little bit crazy. So yeah, purple has to continue. So we get this border, and now green has to continue. 1, 2, 3, 4, 5. So green needs 1 more cell. It can't take this one because, actually, could it? If it took this one, we'd have all these borders, and this would then be a 2, adding with 6, and this would be 1, and then this would be 3, and that actually works perfectly. So maybe it is that, but I can't prove it. Where does 4 go in green? It either goes here, or green grows right to exactly here and puts a 4 there. The 4 is in one of these 2 cells. I don't know if I could mark that, I guess. I don't know if I will remember what that means. Purple has to continue. Can purple grab this one? Maybe. No, it can't. Because if purple grabbed this, it already sees 3, but there's a 3 in purple already. So purple does not go down, which means purple does go right. So that's 5 digits. These are not 1, 3, 5. So these are 2, 4, 6. Now we know purple doesn't take this because there's a border there. So purple doesn't go up or in here. And so this is a new region, which actually is going to have to get out. So it's going to draw all of these because it starts here, it has to get out to here. Now there's still only one way to get out. There's still only one way to get out. This is our yellow region. All right, so we can draw that border. Now purple does have to finish here, and it is done. And this is 2 or 6 only. So there's definitely a 4 in one of these, which means this is not a 4. Now green must take a 4, and it can't get one to the right, so it has to get one down. Oh, and I forgot to draw this border here. And so this is the green 4, and now green is done. And now this can't be yellow, and it can't be orange, so this is a new region. This is our final region. Oh, sorry, I skipped red, so let's just make that red. Red has to get out. Yeah, and we have one more region, which will be blue. Okay, this is 1, 3, 6. Okay, this gets out this way. Okay, so this could be 2, 6. Otherwise, if it's a 3, we need to go one more cell and be 3, 1, 4. Right? No, 3, 1, 5. 4, 3, 2, 4. Okay, I don't know what to do with that right now. Yellow has to keep going. 1, 2, 3, 4, 5. What are these two digits? We have 1, 2, 3. We need 4 and 6. And so then these are not 4, 6. These are from 1, 2, 3, 5. That's not a 5. For what it's worth. This is a 2, 4, 6 triple. So this is 1, 3, 5. Okay. So yellow could take this one. Could this be 2, 6? I don't see why not. This cell here can't be reached by yellow. I think red could reach it. Red could do something like this. That actually looks really good. Okay, so what am I missing here? Is there any forced movement? Maybe we want to think about this 10 clue here. So it sees 4 digits, like 1, 2. It can only see 1 to its left, so it's got to see more downward. That's one piece of logic. Got to see at least 2 more downward, because it's not seeing any to its right, and it's above it. So to its left, it could see a single cell there, and these have to be from 1, 2, 3, but it can't get a 3 from here. So it's going to have to get a 3 from exactly right here. Very nice. That makes that 2, 6, and then now we have to draw that border, which means it has to get out this way. Then it has to get out this way. Yellow has to continue here. We make this border. And now if... I want to say red takes those 2. I think it does, but I don't think I can prove that right now. We can get the 6, 4, and 2 here. We can get our 1 here, our 5 here. Maybe Sudoku saves us. This is 4 and 6. This is 5 and 1. That's not a 1 that makes this... Oh, sorry. That makes this... This is not 1. Not 2, I mean. This is from 1, 2, 3. Okay. I need to draw this border and this border so that the 4 doesn't see any more. Orange needs a 5. Oh, that means that this is definitely blue, because red can't reach it, and this has to be a new region. It has to be a border with orange. I mean, we need a 5 from orange, and none of these can give it. So it has to grow here and grab a 5 exactly. Oh, it can't grab a 5 from there either. So it's going to grow 2 more. I think it has to get a 5 from this column. It can't get a 5 from this column. Can't get a 5 from this column, because this has to be 1, 2 in order for it to outright. In fact, that makes this 6 and 5. That's a 3. This is a 2 and 6. And so orange needs to get a 5, and it can't get it from this column, or this column. So it's got to get it from this column, which means it takes a straight shot there. Now orange is done. And so now this is the 6 and the 5. So that's a 2. These aren't 5s. Red can't reach any farther than right here, but it's got to... Red has to get out. Now this cell can't be isolated. Red is done. And then blue takes the rest. Alrighty, so that's 1. These are not 1s. This is a 4. Okay, let's just finish plonking here. 1, 3 pair, that's a 5. This is not 2 or 3, so this is a 1, 2, 3. This is 2 and 1. This is 3 and 1. Our final digits are 3, 4, and 6. The 3 goes here. The 4 goes here, the 6 goes here, and we're done. All right, actually really clean puzzle, GDC. That's amazing that we only needed these clues, and then the rest, just the fact that we had to make the chaos construction regions and Sudoku finished everything. All right, well, clearly Lily needs my attention, so I'm going to stop here. Thanks again, GDC, and if you enjoyed this, why not leave a like, subscribe, and a kind comment below.